Now, there's two aspects of considering what a strong algorithm is, and we're talking about symmetric. Remember, symmetric is using substitution, transposition. And basically what happens is when an algorithm is created, cryptographers will go through the logic of the algorithm, they'll test it, and they'll be looking for certain types of flaws. And one requirement is there needs to be enough confusion, which means that somebody cannot detect, the bad guy can't detect if one character is changed out with another character, which is substitution, how that results in the ciphertext. So just when you do one substitution, the algorithms should be so complex that the bad guy can't reverse engineer and figure that out. So they shouldn't be able to predict the type of changes with substituting one character and how that will result in the ciphertext. Because really, we're going to look at how these types of algorithms work, but you have so much different types of things happening. You shouldn't have that relationship of you change one component, it always ends up in this ciphertext pattern. Now, that's confusion. Diffusion is different. Diffusion has to do with transposition. Remember, transposition is just moving around the actual values that we have. So diffusion means that the plain text, when it's manipulated or there's changes that takes place during the encryption process, that many pieces of the ciphertext is actually affected. So if you do a transposition on a part of the plain text, it shouldn't just affect this one part. It needs to affect different parts of the ciphertext. These are concepts that most people, unless you're in cryptography, this is a new thing and it's kind of a little bit difficult, but it's important. You could see things like this on the exam. So confusion is usually carried out through substitution, and diffusion is usually carried out through transposition. And the reason what they are is basically there needs to be enough confusion and enough diffusion to indicate that a symmetric algorithm is strong enough.